Welcome back, everybody. So you have waited long enough. Finally, we're going to do it. We're going to do rock facts. So despite how slowly things move on a geologic scale, Earth's surface is constantly in motion. Things are never static or staying still, but is constantly changing over time. One sort of rock is becoming another sort of rock, is becoming another sort of rock, is melting down into magma, is solidifying as an igneous rock, is being transformed into metamorphic rock by heat and pressure, is getting ground down into sediments. Constant motion, and you can see all of that on this cartoon here. Now, if you know what is going on in this diagram, then you know everything you need to know for the section. Let's take a timeout real quick here. What is the difference between a rock and a mineral? Well, a rock is something that is naturally formed like a mineral. It is coherent, solid, like a mineral, but it is a mixture of these different mineral building blocks put together. And these rocks that we see on the surface record the history of the Earth. So here's where we'll start. You might imagine you have a volcano at the surface, and then underneath the volcano is the magma chamber, which is supplying all of the liquid rock for the volcano. And over time, over long periods of time, that magma chamber starts to cool off. Slowly, it crystallizes, it gets more and more solid, and what it forms is something called an igneous rock. What about what's coming out of the volcano? Well, it spews all this lava out all over the place, running down the side of the mountain, and over time it gets down, it pools, it cools, it settles, and it forms this thing that is also an igneous rock. And everything that we see on this picture here is an igneous rock. You have some that are your normal granites. This is the magma chamber slowly cooling over time. We have things that look like granites but maybe a little bit different, chemically formed in different places, maybe in the sea. You have others which look more like lava rock. You can see these tiny holes in them where gas bubbles would have been escaping as the rock cooled. These are called vesicles. You might also see cases like this, where you have some larger pieces in there and some smaller pieces. What it tells you is this thing formed in two stages. So it starts forming in the magma chamber and then later comes out as lava and cools again. So you might imagine that we have a mountain and we start tearing pieces off of this mountain. It's big, it's exposed to wind, water, all of the elements. It breaks down really quickly and all the rocks are flowing away. Well, you take all those pieces of rock broken off the mountain, call those sediments, and you put them in a big ditch and you glue them together somehow, and the result would be something that looks like this. Well, sort of. It's a sedimentary rock. Usually that gluing together process, the process where all these different little grains become solid rock, this happens close to the surface of the Earth, low temperatures and low pressures. Those individual pieces in it, the little grains of rock or sand or whatever, those are called clasts. You're going to get a lot of earthy colors on this, greens or grays or browns and reds and yellows especially, and you're going to get these gritty sort of textures. You think of sandpaper for these. So you might imagine our mountain is right here, and there's these pieces constantly falling off the mountain and down the river all the way down here into the ditch filled with water. You might call this, the coastline. And these eroded sediments start to pile up in layers. We might get slightly different sediments depending on the time of year and which part of the mountain we're breaking down here. We have layer after layer after layer pile up. And now the gravity of the layers on top squeezes the layers on bottom, presses down, and it actually squeezes all of the water out. And then for our last step, you might imagine salt crystals or, glue, something else comes in, and it finally starts to hold all of these different little pieces of the mountain together, and what we have are these layers of sedimentary rock. Now, the process we just talked about is the way that your normal sedimentary rocks are formed, classic sedimentary rocks. The stories on some of these are a little different. For example, if you look at this one here, number 1, 2, 3, 4, 5. 5 is going to be the first number in the access code 5. This one is going to be a little bit different. So you don't have pieces coming off of a mountain. Instead, you might imagine a deep ocean setting where you have these little chemical bits and pieces being precipitated out at the bottom. For the most part, though, the story is for this sandstone here, for the conglomerates at the bottom, is exactly the same as what we just talked about. Now, you might imagine here that we take a rock, could be a sedimentary rock, any kind of rock in the world, and we bury it deep in the earth, get higher and higher temperatures as you get deeper, higher and higher pressures, but it's not enough to melt it. Instead, you just kind of cook it. Maybe you burn it a little bit. The result would be this thing that is a metamorphic rock. So we can take an example here. You imagine we take a bunch of mud and we turn that mud into a rock. Well, what you would get there is called shale. and you take that shale and you bury it deep in the earth, more and more pressure, more and more temperature, it starts to go through these sort of changes, right? We got medium rare here, and then like medium well, and then once it gets to well done, it becomes this thing called a gneiss. And you can see on this one, there's these little layers, black layers running along. This is not something you would see in an igneous rock. It's something called foliation. It's a sort of fabric to the rock. And something you'll also see are these kind of squished or elongated grains inside of there. This is one of the other ways you can tell that what you are looking at is metamorphic. Now these are all metamorphic rocks here, and they kind of look similar to the igneous rocks we looked at before, but how can you tell the difference? Well, biggest thing would be, you notice this one has this sort of layering to it, this kind of fabric. This one also has the layering to it, the foliation. So that's how you know. That's not something you would see with an igneous rock. This one you would have to tell just by looking at the sort of minerals that you have. These are metamorphic minerals here. This one you would be able to tell because it is shiny. So let's put it all together now. We have rocks which form in magma chambers or from lava, from liquid rock. These are called igneous rocks, like ignite, fire. You have these things called sedimentary rocks. Right? You have this mountain, and it is slowly being chipped away, and those little chips are deposited out here in this big ditch, layer after layer build up and solidify into rock, sedimentary rock there. And you might have rocks under high heat and pressure being cooked, well done over here, maybe a little bit medium rare over here. These become metamorphic rocks. Now, you should be able to point out just about everything on this diagram at this point and explain it. What is the key takeaway, though? The key takeaway is this is a recycling process, right? One kind of rock becomes another. Those same materials, though, are recycled into another rock, back and forth through the rock cycle. In other words, those minerals, the basic building blocks, the little Legos, can be used in all sorts of different ways here. The mineral quartz, for example, can be found in granite, but it can also be found in sandstone in kind of a different form. It can also be found in a gneiss, which is a metamorphic rock. And the same is true of these other minerals, feldspars, which are very, very common, muscovite, biotite, these sort of light and dark minerals that help give something like granite its light and dark colors. All of these building block minerals can be combined in different ways to form different rocks. For our final section, we're going to look at mineral mining in Arizona.